Good evening, everybody. Well, tonight we're going to take a look at division properties of exponents, and this should be pretty straightforward because it just builds upon what happens when we multiply, where we added the exponents. In this case, we're going to divide with a common base, and in that case, we're going to end up subtracting the exponents. So it's a pretty easy concept. We'll take a look at how to solve word problems that sound very busy, and look at what I call the 10-2 method. I really want you to pay close attention to how that works and how that helps you set up problems. And then we'll have plenty of practice in class tomorrow. Okay, so let's get started. Okay, so first of all, let's just take a look at what this really means. Well, this means that I have 1, 2, 3, 4, 5, 6, 7, 8 threes, and they're being divided by 2 threes, or 3 times 3. And we can cancel out, and we're left with 1, 2, 3, 4, 5, 6. So obviously that method is really painful. So the other thing we can take a look at is that we can, if we have a common base, we can take the numerator minus the denominator, and that will tell me what my exponent is. So my numerator minus my denominator when I'm dividing with a common base, and that will tell me what my new exponent is. So using that rule here, we have a common base of x. I have a 5 and a 7. 5 minus 7 equals -2. So my answer is -2. And we can leave it like that, or we can leave it like that, depending upon how the answer calls for it. Okay, let's keep going. All right, here it looks like we don't have any common factors until we take a little bit closer look. The first thing we're going to have to do here is we're going to have to clean up this. So let's rewrite this, x to the 5th, y to the 9th. And using the rule that we used yesterday, we have xy multiplied by itself 4 times, which means I have x to the 4th and y to the 4th. Now I have a common base here, and so I have x, 5 minus 4 is 1, y, common base, 9 minus 4 is 5. Let's change that problem just slightly. Let's say we ended up with something that looked like this. Well, that would give me x, 5 minus 8 is -3, y, 9 minus 3 is 6, and then we would have to clean that up one more time. Y over 6 and the x over 3 would go down into the denominator using the rule that we learned when we learned initially about negative exponents. Okay. Now the reason it's so important is that when we're dealing with very large numbers, if we can understand the exponent rules, then we can save ourselves a lot of time. And I showed you this in class today, but I want to go over it one more time. We have 2 times 10 to the 8th. We're going to put a bar, 8 times 10 to the 5th. And now we can see we have a common base. And so with the knowledge that we have a common base, I can do 8 minus 5 is 3. And then I just finish up here. 2 divided by 8 is 1/4, which simplifies to 0.25 times 10 to the 3rd. And I know I say I love fractions, but in this case we have to write it in scientific notation, so we have to convert it to the decimal form. And this is not in scientific notation form, so we have to move the decimal. So I move the decimal one place. I made this number bigger, so I need to make this number smaller. I made it bigger by a factor of 10, so I make this smaller by a factor of 10. And there's my answer. Okay. Now finally a little word problem. And this is really where you're going to use this to solve your problems. Excuse me. But if you don't know how to set it up, it makes your life really hard. So let's take a look at this word problem. In the year 2000, the U.S. debt was about 6.6 times 10 to the $12, and the population was about 2.8 times 10 to the 8th. What was the average debt per person? Well, the biggest problem that people have when they read problems like this is they really don't know where to start. The numbers are so huge that we really forget what kind of math is this? Is this addition? Is it subtraction? Multiplication? Division? What do I do with all these numbers? So let's go back through and take a look at a method that will help you with this. And this is what I call the 10-2 method. And all I do here is I assign randomly to, and this can work if you have more than two numbers, but it works well with two numbers, is I just randomly assign the 10 and the 2 to the really large numbers. So I come through and I just put a pen through it. All right? Now which of these numbers was bigger, 10 to the 12th or 10 to the 8th? Well, 10 to the 12th. So I'm going to make this now 10. It's no longer that big messy number, it's 10. And over here, it's no longer that big messy number, it's 2. And I'm going to rewrite the word problem, or I'm going to read the problem again. In the year 2000, the U.S. debt was about $10. And the population was about 2. Okay, so the population is 2. What was the average debt per person? Well, now we know. How many people were there? 2. The average debt, the amount of debt was 10, so it's 10 divided by 2. So which number gets divided? Well, now we know. We know that this number up the top, to the 12 and to the 8, this number on the top gets divided by this number right here. And all I do is I use that as a technique so I can see. For me, my brain works a lot easier knowing, hey, the debt was $10 over a population of 2. What was the average debt? Well, that's easy. 2 people owed $10, so it was $5. It was 10 divided by 2. Now I can go back to the really hard problem. Same rule applies here. So 10 to the 12th, 10 to the 8th, so I end up with 10 to the 4th. 6.6 divided by 2/8. I don't have my calculator in front of me. And I get 2.357. We'll say that's enough significant digits. Okay. And since it's already in scientific notation form, I don't have to do any movement. Okay, so I hope this helps. I hope that when you're deciding whether to multiply, divide, add, subtract, that you use the 10-2 method by plugging in the numbers just to take a look-see and help you figure out which operation you're going to use. And we'll have a chance to practice tomorrow. Good night.